numbers, I go to 0. Okay. Okay, number 2, what do we get? From the left, if you look at from the left, what's the number to the left of 17? It's really, really close. 16. Wait, go left. No, left. We're right. 16.99999, right? What's if I put 16.99999 in, right? I would get a negative something on top and that same number on bottom, but that's positive. So I'd get negative 1. What if I pick something to the right of 17? 17.001. Same thing, it'd still be 1, except I would get a positive 1. So from the left and right, I'm getting 2 different things, so that limit does not exist. Another infinity one, so I'm going to look at the leading terms. That does reduce to 2/3 times x. Does everyone agree with that? As x approaches negative infinity, what does that approach? Negative infinity. Do make sure you check this. Don't just say negative infinity because that says negative infinity. If that had been negative 2/3, then that would be positive infinity. Or if that had been 2/3 x squared, that would have been positive infinity. So be careful, always check and see what's happening with the numbers. Number 4. Sine of x 6 factors negative 1 and 1. I'm approaching infinity, so I'm trying to think of which one grows faster, right? E to the x grows faster than anything you know. E to the x is really fast, natural log is really slow. Most things fall somewhere between those two. Okay. But sine doesn't grow at all, right? It stays trapped between the two. It's the bottom 3. If you are not, which I know today with review you haven't seen a while, if you are not going at about the pace I'm going, you'll have to speed up. These should be quick question answers on AP. What's this one? We're approaching infinity. That's all that matters. That reduces to 2/3. This one's kind of tough, but you do have 2 options. My calculus class right now has to use special limits to do this. The sine of x over x limit. So they have to multiply this by 4 on top and bottom. And then kind of regroup. This piece equals 1, so it reduces to 4/5. So that's why they have to do it. You could use what? L'Hopital's rule, and if you do L'Hopital's rule, the derivative of sine of 4x is cosine of 4x times 4. And you go to the bottom is 5, and then you can plug in 0, and you get 4/5, right? So L'Hopital's. What are the rules for using L'Hopital's? What do you use L'Hopital's? 0 to 0, or infinity over 2. They want to choose that. What about this one? How'd you get 0? I don't have to do that. Plug it in. What's the first thing you always do? Substitution. Always. You will do lots of extra work if you don't do that. I put a nasty square root one on there, my AP calculus last homework, and it was all they had to do was plug it in. I saw lots of multiply by conjugates and beautiful nasty work. This was all right and simply unnecessary. Be careful. Plug it in, just plug it in. Number 8. That's another special limit when I can factor the 3 out on top. And cosine of x minus 1 over x, the limit as x approaches 0 is 0. So if you're using special limits, it's 0. If you don't want to remember those special limits, you could use L'Hopital's rule on that also. Did we get 0 now? The next one, what do you get when you plug in 5?
Oh,
You get 0 over 0, right? Which lets you know there's more work to be done. Now, I remember saying that last fall for last spring. If you get 0 over 0, there's more work to be done. You can use L'Hopital's, or you can factor and cancel. Both work great. I think factoring and canceling is probably faster. But it's up to you. X minus 5 and x plus 1 on the top. So we do get 6. The one on the right, what do you get if you plug in 1? is if you recognize that as a definition of your which is radical 2 over 2. You could also have used L'Hopital's rule if you got stuck on that one. L'Hopital's rule is